Hi everyone, this is Geeta. Now we are going to learn about the topic implement and demonstrate the Q-learning algorithm in and machine learning. First, introduction. In the Q-learning algorithm, the reinforcement learning it is an interdisciplinary area of the machine learning and also the optimal control concerned with how the intelligent agent to take an actions in a dynamic environment in order to maximize the cumulative reward. Here, the basic components are four. These are agent, environment, actions, and the rewards. In the reinforcement learning has four essential components. First one is a policy and a reward and a value function and an environment model. These are the four essential components and the four basic components are agent, environment, actions, and the rewards are the reinforcement learning. Then the Q learning. What's the meaning of Q learning? Here, the Q learning is nothing but a value-based reinforcement learning algorithm. In this Q learning algorithm, here it is a module-free and the off-policy reinforcement learning that we will find the best course of action by given in the current state of the agent. By choosing the current state of the agent, we are going to find the best course of an action in the Q learning. Q-learning it is called as a model-free and it is also one of the off-policy reinforcement learning. It is used to find the best course of the action by choosing the current state of the agent. The use of Q values to iteratively improve the behavior of the agent. By this Q learning, the Q values can iteratively improve the behavior of the agent. Then the uses of the Q learning are Q values to represent the expected cumulative rewards of taking a particular action in a particular state. In the Q learning, the Q table is we can build a Q table. Building a table of a Q of S of A values. Here, the Q table is a lookup table where we calculate the maximum expected future rewards for action at each state. Here, first we are doing the initialization and we are updating of the Q values based on the agent's experience. To learn the each value of the Q table, we use the Q learning algorithm which involves an iterative process of updating the values based on the agent's experience. Here, we are going to learn the each value of the Q table by using the Q learning algorithm. It means it involves the iterative process which can update the values based on the agent's experience. This is nothing but the Q table. Then the basic Q learning algorithm. Here, there are some key steps in the Q learning algorithm. The key steps are first one is Q learning is a module free and the reinforcement learning algorithm to learn the value of an action in a particular state. It's nothing but it does not require any model of the environment and it can handle the only problems with an stochastic transitions and rewards without requiring the adaptations. The first key step in the Q-learning algorithm is it is one of the model-free reinforcement learning algorithm. It is used to learn the value of an action in a particular state. It no need any require of the model of the environment and it can handle the problems within stochastic transitions. Then the explanation phases. Here the second step is exploration and the exploitation phases. The first exploration is nothing but trying a new action. Then exploitation phase is nothing but choosing an action based on the current knowledge. Here in the Q-learning algorithm, it involves a balance between both exploration and the exploitation. It's nothing but trying a new actions and choosing a actions based on the current knowledge to find the optimal policy. This is the basic Q-learning algorithm 2 steps. And we learned that Q-learning it is one of the off-policy learning. Here we are going to discuss the off-policy learning in the Q-learning algorithm. Here, Q-learning takes an off-policy approach because to reinforcement the learning aiming to determine the optimal action based on its current state. Mainly Q-learning takes and its aim is to determine the optimal action based on its current state. The agent's ability to learn the Q values regardless of the policy being followed. Here, Q-learning allows the agent to learn the Q values independently of the policy being followed, which contributes to its robustness and flexibility. One Q-learning example is, first step is a Q-learning. It can demonstrate how an agent learns to make a decisions based on the Q values. A Q-learning, it can demonstrate an agent learns to make a decision, how an agent learns to make a decision based on using the Q values associated with different actions in various states. In the second step, it's going to takes place the initialization, action selection, and the Q value updates. It means while doing the Q learning process, it involves the initializing and the Q table, then selecting the actions, and it as usual updating the Q values based on the rewards received. In the first step, it is used to demonstrate how an agent learns to make the decisions based on the Q values associated with different actions in the various states. In the second step, it is going to take place the initialization, action selection, and the Q value updates. Here, first process, it involves the initializing the Q table and selecting the actions and updating the Q values based on the rewards received. Then convergence and optimality. Here in this Q learning algorithm, convergency and optimality is nothing but first we are going to discuss the convergency of Q learning. Q learning, it mainly aims to converge to an optimal policy by iteratively updating the Q values based on the agent's experience and the rewards received by the agent. Then optimality of the Q learning, the goal of maximizing the Q value to find the optimal action selection policy. The main goal is maximizing the Q value to find the optimal action selection policy. Here, ultimate objective of Q learning is to maximize the Q value for each state action pair to determine the optimal action selection policy. This is the convergence and optimality. In the convergence, iteratively update the Q values based on the agent's experience and the rewards received. Then in the optimality, its main goal is to ultimate objective of Q learning is to maximize the Q value for each state action pair to determine the optimal action selection policy. The applications of Q learning are in the real world applications of Q learning, like example, game playing and robotic control. Then the second application is Q learning has been successfully applied to various real world problems including the game playing, like example, game playing and robotic control and optimization tasks. Then it also successes the stories and challenges in applying the Q learning to complex the problems. Here, while we doing the Q learning has shown a success in many domains, like example, game playing and the robotic control and the optimization tasks, and it also presents the challenges like examples such as scalability to large state spaces and the complex environments. Thank you.